Welcome to Florence. when you get off your bus from the cruise ship, well, you're going to see the bridge, the Ponte Vecchio, and oh, you can't miss the Uffizi Museum. And if you're finished with those, right here in this corner is something just as important, the Galileo Museum. Of course, now, almost 400 years ago, Galileo first turned his telescope towards the sky. Galileo was the first one to see the moons of Jupiter or the rings of Saturn. Galileo would invite other people to look into his telescope, but some learned minds of the day refused to look into it. They thought it was some kind of trick because it showed things circling something other than the Earth. If you were to go to an astronomy lecture in the year 1609, the lecturer would tell you with every certainty that our Earth is fixed for all eternity at the center of the universe, and the sun and the planets travel around the Earth. But anyone looking at the planets for any length of time will see that sometimes they appear to move backwards in their orbit as if they were circling something else. Now, to explain that, the learned minds of the day concocted epicycles, wheels within wheels. Epicycle theories were very popular because any mathematician could come up with a new one. Some of them had 40 or even 100 little circles to explain the motion of planets. Of course, what Galileo saw was that Earth is not the center of the universe. It and the other planets revolve around the sun. Now, at the same time, there was another controversy, whether light had any speed at all. Now, many great minds of the day, like Johannes Kepler, thought that there was no speed of light. Light just simply traveled everywhere at once, instantaneously. Now, Galileo himself suggested doing an experiment, placing lanterns on distant hills and timing the lights traveling between the hills. But Galileo, didn't have a distant enough hill or a good enough clock. Galileo could only conclude that if light had a speed, it was just too fast for him to measure. But the first evidence that light had a speed came from another one of Galileo's discoveries, the moons of Jupiter. Slide, please. This is a special place, Paris. And this is the Paris Observatory. Now, who's been to the Royal Greenwich Observatory outside London? Great. Now, and did you stand on the line marking the prime meridian? Okay. Has anyone been to the Paris Observatory? Well, there you can also stand on a line marking 0 degrees, because at one time there was a competition between Paris and Greenwich who could have 0 in their backyard. Now, by the 17th century, there was an anomaly, a mystery about the moons of Jupiter. Astronomers would try to predict mathematically when the moons would appear from behind Jupiter, but sometimes they would just show up late. Now, an astronomer working in Paris named Ole Romer realized the delay was due to the speed of light, the time it took for the moon's moonlight to travel across the solar system and reach Earth. Particularly with the innermost moon, Io, which was discovered by Galileo, Romer calculated that on a certain day in the year 1676, Io would appear 10 minutes late from behind Jupiter. On that day, Io appeared late, right as Romer had predicted, but at the time, almost no one believed him. Most astronomers at the time believed there was no speed of light. Now, next slide, please. Now, today, the speed of light, which is part of our science, it's measured out. It's by 299,782 kilometers per second. Why is it that speed? Not faster, not slower? Why isn't it instantaneous? Has been a mystery. Now, I'm going to skip a lot of math here because there's not a lot of math in the book, just one easy equation. But as Albert Einstein said, when forced to summarize the general theory of relativity in one sentence, time and space and gravity have no separate existence from matter. Now, I found a way to express that in a very simple equation. In fact, I discovered the very equations, the very code that causes our universe to exist. And it looks so simple. Just one click, please. I just click it once, please. See? Gm equals Tc cubed, where G is gravity, M is mass, T is time, and C is the speed of light. You can see that, see? This is simple. Has everyone had algebra? But But this was not discovered until now. It's a new equation. People have a hard time believing it. After all, a woman thought of it. But this explains everything about the universe you wanted to know, but we're afraid to ask. How big it is, how old it is, why it expands, whether it's ever going to stop expanding. And it also predicts what the speed of light is. Not just now, but what it was in the past and what it will be in the future, because this predicts the speed of light has changed and is still changing at a small rate right now. Now this would solve many, many problems in science, even on our own Earth. Next slide, please. One of the things it explains is our beautiful climate. Like, see, we enjoy a great climate on Hawaii, but according to theories of our sun, life shouldn't have evolved on Earth at all, because the early sun was only 3/4 as bright, and Earth would have been colder than the movie Frozen. But that can't be true, because there's plenty of fossil evidence that there was life several billion years ago. I was fortunate to work with a team at Johnson Space Center who found signs of life on a meteorite from Mars, 3.5 billion years old. And that's very controversial, but since then, other scientists have found conclusive evidence that early Mars had liquid water, even oceans. Something was keeping both Earth and Mars warm enough for life when theories of the sun say it was too cold.
I don't know what happened.
Okay, go just back one.
Go back. Okay, there you go.
Well, the sun turns its fuel to energy by that old Einstein equation, E equals mc squared. Turns out if c, the speed of light, was exactly as much higher as that equation predicts, Earth's temperature early on would have been almost exactly what it was today. In fact, some things nearly are constant, and the amount of light we receive from the sun has been nearly steady over several billion years, which has allowed our life to evolve. So, in other words, if the speed of light hadn't changed in exactly the amount predicted, we wouldn't be around to talk about it. And it solves another problem. Next slide, please. And one more click. How the Big Bang started. What set it off? And one more click. This is, you've probably seen this. This is the cosmic microwave background, which is radiation which comes from all around the sky, which is left over from the Big Bang. People didn't understand why this happened, or why there was a Big Bang. They have plenty of evidence, but what caused it? It turns out it's the one equation. Further, they didn't understand why the temperature is so similar all over the sky. This was big news about 5 years ago, 2014. There was an old theory, they called it cosmic inflation. They came up with this theory, but they couldn't find any evidence for it. So they didn't throw out the theory, they just kept looking for the evidence. Finally, 5 years ago, they held a press conference. It was on the front page of the New York Times. They had discovered gravitational waves from the beginning of the universe, which proved their inflated theory. That was on the front page, but a few months later, other scientists looked at the data and said, they saw dust in the telescope. Since then, no one studied that theory, but this would explain this leftover radiation far better than any inflated idea. And finally, would explain what's considered the biggest problem in physics, the so-called, go forward please, the so-called acceleration of the universe. Now, people have measured that the universe is expanding because the farther away a star is, or a galaxy, the farther its light is shifted into the red, as if the different parts of the universe were expanding away from us. When they looked at very distant exploding stars, supernovae, they found that their redshifts were actually accelerating, as if that part of the universe were accelerating away from us. This has been a big mystery. Oh, but in February, a lecturer came into the Helu Theater and told us they were certain that the universe was accelerating. Was anybody there?
Yes.
Okay. But they missed something so simple. And it was explained by another Nobel Prize winner. Slide, please. Dr. Martin Luther King. This is the Martin Luther King Memorial in Washington. On the marble wall behind Dr. King is one of his sayings, "Darkness cannot drive out darkness, only light can do that." what they were observing wasn't the universe accelerating due to some mysterious dark energy, but it was the speed of light slowing. Now, again, this is still not common knowledge. It's still much more, I read fashion magazines too. It's much more fashionable to say the universe is accelerating due to some dark energy. But there are other ways of measuring the speed of light. You can keep it here. Now, Galileo wanted to measure the speed of light by placing lanterns on distant hilltops, but didn't have a distant enough hill. Now, we've had a distant hill since almost exactly 50 years ago, July 20th, 1969. This is called a lunar laser ranging experiment. It was left on the moon on that day by Armstrong and Aldrin. It's made up of just little reflectors, just like bicycle reflectors. Now, by bouncing lasers off this, scientists on Earth can measure the moon's distance down to the centimeter. Now, before and during my work at Johnson Space Center, I examined data from this thing, and it showed that the laser light had been slowing over 45 years. And that was published, back in the year 2012. It's still controversial, but the paper's been viewed over 10,000 times. Again, this is still not fashionable. After all, a girl thought of it. But enough people believe in this to have built, next slide, the space station. Now, the space station allows many different kinds of science to go forward. And something exciting that's going up next year is called ACES, Atomic Clock Ensemble in Space. The other way to complete Galileo's experiment is just to build a better clock. Now, ACES is going to be the most accurate clock ever made, because in orbit, an atomic clock is more accurate than a clock on Earth, because Earth's gravity will not interfere with the vibration of the little atoms. Now, this is funded, it's built. It doesn't get a lot of publicity, but we've spent about $50 million on this thing. It's going up to the space station next year. One of its principal goals is to search for changes in the speed of light. Will ACES find changes in the speed of light? Will signed copies of this book be worth a fortune? Time will tell.